Hey everyone, and welcome to this tutorial on the ultrasonic sensor. In this tutorial we're going to use the HC-SR04. It's a 4-pin ultrasonic sensor, which is pretty standard. If you go looking for an ultrasonic sensor for an Arduino or something, this is pretty much what you're going to end up with. It has 4 main pins. You've got the voltage coming in here. Voltage is 3 to 5 volts generally. 5 volts is the recommended. Then of course you've got ground. Ultrasonic sensors, the way they work is they send out a signal from one of these transducers. These are called ultrasonic transducers. And what they do is they send out an ultrasonic signal, and then they measure the distance, the time for that signal to go out, hit something, and then come back and be received by the other transducer. And then measuring that time, and based on the density of air, you can figure out how far away that object is. That's why these are called range finders generally. And what the trigger is, the trigger pin, this is generally connected to a digital pin on the Arduino, which sends a signal, a digital signal that says, okay, send a pulse. The transmitter, T, sends a pulse out, and then the receiver receives the pulse and sends that signal back to a digital pin on the Arduino again. And then you measure the time between those send and receive. So let's just do a quick little visual here of this to bring up some points. Imagine we're trying to find the distance to this blue block right here. So what's going to happen is you're going to send a signal to the trigger pin on the ultrasonic sensor, and what that is going to do is it's going to cause the transmitter to send out a little wave that flies here and hits this block. Then once it hits that block, it's going to come back just like this until the receiver gets a hold of it. And then when that happens, you can measure the time that it traveled through the air. And the way that works is, if you know the density of air, you can know how long, what the speed of sound is through air, and it's generally 776 miles per hour is the speed of sound through air. So that if you know that it's traveling at that speed and it goes to here, it comes back here, and you measure these times. So then based on the time that you send out the signal and the time it comes back, and using this number, you can figure out the distance between these two things, which is really quite useful. The trouble is if you, let me get another part of the sheet, is if your object is either at a weird angle or a weird material that absorbs it like a sponge, then you've got this little signal that comes out here, and then when it hits it, instead of reflecting directly back into it, it reflects off to a side. And then the ultrasonic sensor might not detect it, and that can be an issue. So these are really kind of limited in what they can do. You got to make sure they're always kind of going up against flat surfaces and reflective surfaces. Like I said, sponges, rugs, sometimes your hand, they don't always detect it very well and measure a very good distance because the sound waves get scattered. But other than that, they're pretty handy tools and they're quick and easy to use. That's the general outline of it. So yeah, you use a digital signal from the Arduino to send a signal out the trigger pin, and then you receive the signal from the echo pin, using that time and the speed of sound in the air where you're using this, you can determine the distance to some object based on the reflected sound wave. And here's a pretty good demo of how to use it. We used it with the little arm to create a simple controller. Hope that helps.